Today we're going to talk about Venn diagrams and how to read them. So in this first example here, the scenario says that a survey asks students which type of music they listen to. Out of 200 students, 75 of them like pop music and 45 of them like country music. And also 22 like both. I want to find the probability that a student listens to pop given they listen to country. So we need to find pop given country. So to set this up, I'm going to label my circles here. So I have pop and country music. I know that 22 people like both, so I'm going to put 22 in the middle there. Now for pop music, the whole circle here represents all the people that like pop music. Since we know that 75 people like pop, I have to subtract the 22 that I've already accounted for, because again, that 22 is in this pop circle right here. So to take out those people so I don't count them again, I'm going to subtract 75 minus 22, so I end up with 53. And then for the people who like country music, I'll do the same thing. There's 45 of those, and I subtract this overlap of 22 that I've already accounted for again, which gives me a total of 23 people. And now to find the probability of pop given country, the given, remember, is what we're focusing on. So we want our total to be out of all the people who like country music, which is 45 people. Now out of those 45 people, we know that 22 of them like pop music because that's part of this overlap here, this intersection. So this part of country intersects with the pop music. So 22 is the number of people who like pop music given they like country. So 22 out of 45, which is 49%. We'll do another one here. We have people who listen to music and people who like to play sports here. And it says that we have 140 students. 37 of those listen to music, and 103 of them play sports. And then we're also introduced to a neither. So 25 people do either of these things. So again, I've got music and sports here. The neither is going to go out here on the outside because we're not part of this music and sports circle, so I have to subtract them out. Again, if I'm out of 140 students, to figure out how many are left in this circle to split up, I'm going to subtract. So 140 minus 25 is 115. So the numbers that I have in this circle here, these Venn diagrams, have to add up to 115. There we go. Alright. So again, we know that there are 115 students. We know that 37 of them listen to music. So if I take away all of those people who listen to music, I'm going to cover up this circle. Notice I'm also covering up this overlap here. Okay, so if I take away those 37 people, 115 minus 37, leaves me with 78 people that must play sports, because I took away the 37 that play music. So 78 must play sports. Now I'll do the same thing to figure out how many people like music. If I take away all the sports people, which is 103, I take away all those sports people, 115 minus 103 leaves us with 12 people who listen to music. And now I can figure out what my overlap is. 78 plus 12 is 90 people, but we know that our circle is supposed to account for 115 people. So 115 minus 90 means we have 25 people that must like both things. And then from there we can answer a variety of questions, such as the probability that a student studies music. That would be everything in this circle. So I'd have to add up the 25 and the 12, which would be 37 people out of 140, because again I have 140 students. So I'm not accounting for just what's in the circles here. It said the probability of all the students. So 37 out of all 140 students study music or listen to music. Alright, we'll do another example. We'll do one more. Let's say we've got a scenario here where we know there are 320 people in the school. 200 of those people play sports. 85 people are in band. And 60 of them are in both. So we have sports here, band, and what we're going to do after we fill in this Venn diagram is, of course, answer a bunch of different questions. So we know that 60 people play both, and I'm just going to do the same thing as I did before. If there are 320 students, 200 of those students play sports, 85 of them are in band, 60 of them do both. So what I'm going to do to figure out how many students play the sports is subtract all the people who are in band again. So if I take away these people who are in band, actually we don't have to do that because we know how many people are in both already. So if we have 60 people that are included in band out of the 85, all I'm going to do is take 85 minus 60, and that gives me 25. And then for sports, again, we've got 60 who do both, so I'm going to take 200 minus 60, which gives me 140 students. Now, the question asks me how many people are not in sports or band, and how I'm going to do that is add up these numbers. So I'd get 25 plus 60 plus 140, which adds up to 225. So there's only 225 people in the school that are in band or sports or both. So if there's a total of 320 students, to find how many don't do either of those things, I'm just going to subtract. So that means 95 students do neither of these items. And again, the reason I didn't have to do like the last example by covering up these different parts of the Venn diagram is because we were already told how many people played both. And I forgot about that. But if we already know how many are in both, then all we can do is a simple subtraction right away here. We don't have to subtract anything using the circles here. Alright, now let's say we wanted to find the probability of the number of people that are not in band. So the number of people who are not in band are going to be the people who are in just sports or don't do any of those things. So that would be this 140 people that are just in sports, not including the 60, because again the 60 is part of this overlap. So 60 people are also in band. So just the people who play sports are 140, and then of course the 95 that are not in sports or band. But again, we want just not band, so that includes these 95. That adds up to 235, and we have a total of 320 students. So our ratio is 235 out of 320. And those are just a couple examples on how to create and interpret Venn diagrams.